Okay, we'll come back to section 6.2, which is the volume using disc or washer. In this section, I will concentrate on the idea of having a washer, and then you can easily generalize it to a disc. So let's see, what is this volume using disc or washer? Now, just please imagine with me that you have this line here. Okay. Let's say this is y equal 3. Okay. And now you wish to take another line. Let me choose now the x-axis. I will always do it with red. This I will call it the axis of revolution. I'll explain in a minute why I call it axis of revolution, and usually instead of writing axis of revolution, I will just write like this. Now, imagine with me what will happen. Fix the red line, this one, fix it up, okay? And take this blue line and take it out of the screen and get it inside again from behind the screen. It's like this blue line will revolve around this axis, like going up and something like this. The shape that we will get is kind of a cylinder. It's a 3D shape. It's kind of a cylinder. And our task in this section is to find the volume of that cylinder. So this, if we revolve it, it will look like this. The dotted means it's from behind the screen, and so on. Okay. Same thing can happen to any other function. Let's do another example for another function. Let me take this one. Take the famous parabola. Okay. And now let me rotate it on maybe this axis. I'm not sure what we will get. It's just you could imagine that you will take this one, take it out of the picture, take it down here like this. It will just rotate in that shape. Okay. Something like this. This is, we call it the surface of revolution. It's a 3D. It sometimes is really difficult to graph 3Ds. And well, our task in this section is to find what exactly we need to find as the volume. So how we will do that, let me go to an example and I'll explain it to you in the example how this can be done. Let's go to example number 1 or question number 1. So question 1. We say just find the volume of course I should have a region like before, like what we did in region bounded by the curves. Now I have a couple of curves. The first one is y equal x plus 1. This is just a usual line. Okay, what else do I have? I have the curve y equal to 0. This is the x-axis. We have the curve, let me do it in yellow, x equal to 0. This is the y-axis, just to remind you. Also, we have this line, which is x equal to 2. Those are the curves that will give me the region. And then I have to exactly tell you where is the axis of revolution. Usually I will just say it will revolve around or about, in this example, the x-axis. Now, before we start doing anything, let's sketch my region. Let's see what is my region is, and then we can think about what we should do next. First of all, y equal x plus 1, the blue region is just a line. If we substitute 0, we will get this point. If we substitute 1, we will get another point, which is maybe this one. And then all what we need to do is we just join them together. This is the first one. Now the second one, which is the green one, y equal to 0. This is, as we said, this is the x-axis. So it's this line over here. Now this one is the y-axis, x equal to 0. Line axis. And then I have x equal to 2. So it says 0, 1, 2. Maybe this one is 2. And now my region will be the one that is between all those colors, and it's clear it should be this one. So this is my region. Okay. Let me write the numbers. We said this is 0 and this is 2. Okay. Now, where is my axis of revolution? Is the x-axis. So again, I have to go to the x-axis, and I will just mark it down. Okay, now this is the axis of revolution. And now if you can look at what will happen, I will take this region here, I will take it outside the board, and then from inside, I will take it from this, I will get it down here, and I will revolve it. So I will get kind of a three-dimensional thing. It could be, this is a trapezoid. So you can just imagine if you take it out and then in again. Okay, now, how do we find the volume? What is the formula using the washer method? I can use the disk method here, but I prefer to use one method for you, which will be the washer method. Washer method. The washer method is very easy, very simple to memorize. The volume will be by, and then we have to integrate from somewhere to somewhere. We'll tell it exactly what. And then we have to find two things and you square them. Okay. The first one is something we call it R out. And then we need to find something, we call it Rn, and then it's dx. Of course, why it's dx? Because all the functions given in the question are in terms of x. So just do it with dx. Okay. Now, how do we find R out and what is R out? Let's do it here. R out, usually we call it the outer radius. Okay. And how do you find the outer radius? All what you need to do, you go and stand on your axis of revolution, take an arrow from the axis of revolution to the maximum you can go inside the region. So you go from the axis of revolution to the maximum inside your region. That is we call it the R out. Okay. So this is what we need to find here. So I should have the R out, should be a line starting from the axis of revolution and going all the way to the maximum. And this is what we call it R out. We need to find what is the length of R out. As you can see from the picture, it is the usual top, because it's a vertical, like what we did in the rectangle before, minus bottom. And the top function is clearly the blue function, which is x plus 1. Negative the bottom function is the red function, which is the x-axis equation, which is y equal, if you want to remember, y equal to 0. So the bottom function is 0, and the final answer is x plus 1. And that's what we need to write for the R out. So I'll go back here. And in solving the question, I'll just write by integral r out square, which is x plus 1, minus the Rn. In a minute we will find it, and that's what we will happen. If you have any question, please ask me, because figuring out which one R out Rn is 70% of the question. Now, what is Rn? Rn is the inner radius. And sometimes we have an inner radius, sometimes we don't have. Let's see in this example if we have an inner radius. Now, for the inner radius, it should be starting from the axis of revolution to the minimum I can go. How much the distance between my region and the axis of revolution. If you could notice here, we don't have any distance. It's almost together, which means there is no inner radius. If there is a space, for example, I'll just do a big example here. Suppose that my region like this, okay, and my axis of revolution is somewhere here. Let's just imagine this is just an example. Now this is my region, and this is my axis of revolution. Then it's clear that R out will be this one. This is R out, and Rn will be this one. But in this case, we don't have any space here. So Rn should be just the 0 function. And we have to plug in this here. Now, there is only one thing that is left for us, is to find from where to where. And that we have to look at our region. If you look at R out, if you move it maximum to the left, we reach to the 0. If we move it maximum to the right, we will reach 2. So this one should be from 0 to 2. Again, this is kind of a basic math 101 integral. We can solve it just because this is the first example. So this will be by integral from 0 to 2. If we expand this one, it will be the first square plus 2 times first times second, 2x plus 1. 0 square will just gone, dx. And then you just have to write by integral from 0 to 2. Oh no, we don't need now the integral because I'll just do the integration all at once. x3 over 3 plus x squared plus x, and this is from 0 to 2. The final answer will be 8 over 3 plus 6, which is 26 over 3 pi. Of course, it should be unit cube, but we don't have a unit here, so we just keep it as this. Okay, that's how we find the volume using the washer or disk method. We sketch the region as we do before. We use this formula. Let me highlight it for you. We use this formula. And we need to find R out is the distance from the axis of revolution to the maximum in the region. And then we have to find Rn, which is this distance. And then we just put them here with the squares, and that's what we get. Please write for me in the comment if you have any